Do I vape?
Do you vape, Mr. Goose?
No.
I saw you back there hitting the vape.
What?
She's hitting that nipstick. She's hitting that nipstick.
Y'all don't need any more mental health or anything. God, what a bunch of goobers. Okay, questions about your homework going once.
Number 9.
Number 9, open dots. That means I'm leaving out just that one point. So it does something like this, but this is an open dot right here. If you find the coordinates of that point, it looks like -1, -4. So that means x left to right could be anything except -1, right? So I do those back-to-back parentheses to leave that out. So -infinity to -1, and then I pick back up -1 to infinity. And then the range would leave out the -4. So -infinity to -4 and -4 to infinity. So I'm just leaving out just simply that one value and nothing else. Good question though. And that is a function, yes. Yeah. You mean multiply it out? Like 21 and 19, like FOIL it out? Yeah. And then if you can factor, yeah. Yes, if you can, yes. Which one did I tell you no on? It's okay. It's okay.
Wouldn't you just plug it in?
Yes. Yes. 21.
I don't want. Oh my God.
All right, this asks me to find t of x plus 4. So I'm going to take x plus 4 and plug it in for the x there. Some of you got confused. I had several of you. In fact, I feel like it was at least 2 in here, and maybe it was Kinsey. I can't remember. Talking about an infinite loop. I heard that word more than twice yesterday in this class. Was that you, like after class? Okay. Once you plug it in, you don't plug anything else in. Logan, leave Miguel alone. You only plug it in once. You don't keep plugging in every x every time you simplify it down. You just plug it in the one time. Now, in the simplification process of this would be an x plus 4 3 times, and then this would be minus 2x minus 8. So if I multiply this out, though, leave them alone. I would do only 2 at a time. So I'd multiply the first 2, simplify it, and then take that to the third. Don't try to go boom, boom at the same time. Does that make sense? Okay. I figured somebody did. This does not equal this. What else?
Oh my God.
On your homework.
Yeah, what's 16?
X squared plus 8x plus 16 times x plus 4, which would be x cubed plus 8x squared plus 64. Nope, I jumped ahead. Plus 16x plus 4x squared plus 32x plus 64 minus 2x minus 8. Which is, if that wasn't in my head, I did it out. When you distribute a -2 through it.
2y.
That is next month interest, yeah. 16 and 32 would be 48 minus the 2 would be 46x. 64 minus 8 would be 56. Final answer. That's it, yeah.
This one is easy.
Intro to the unit. That's like background. That was
This was yesterday's one?
function review was what yesterday was. To get us ready for the functions unit. Y'all good? Would you get the same thing if you did? That's why you can't distribute. That's not a property. You can only distribute exponents if you are multiplying or dividing in the parentheses. Never if you add or subtract. How many times did I tell you that? Y'all are telling a story. I did it in Algebra 2 a gajillion times.
Yeah, I was here the whole time.
What else?
Hey, nothing.
All right, what else on your homework?
Wait. 13.
13 was a hard one.
Yeah, 13.
13 was a hard one.
How do you do
It was just the concept.
what is God?
I can't grasp that concept. You have to get the Y by itself.
Now, this was kind of new. We've solved equations. We've solved equations before. We've solved equations before, but we haven't really called it solving in terms of another one, solving explicitly for one. So for this one, and we talked about this one yesterday, this is a perfect square trinomial. So if because it's square dances. Double the square, multiply and double. Remember?
I never got that concept.
Oh, we're gonna get up here and do it together. Come on, Noah, multiply and double. Thank you. You get another bonus point today. Huh? Can't factor out y because Evan doesn't have a y to give. Okay, what good is that going to do you?
Whoa, why is it square?
You got to have it solved for y by itself, though. You can only, okay, so if I divide by y plus 6, then I get.
That's what I got too.
Is that only in terms of x? Nope, you got another variable over there.
X over y.
All right, what else?
Whoa, what do you do?
Oh, here I would square root on both sides, and so I get y plus 3 equals x plus 8. Well, they don't care for you a lot either.
I did get that answer.
Did you? You skipped 3 of them. Noah, we're supposed to be friends today. We can't be friends if you don't do your work. I haven't graded it yet. I haven't looked at it. I didn't look at it till just now.
I should have just not even taken it out.
What else?
That was it. Oh, number 2.
Okay. Let's move on to. I don't remember, but I worked it yesterday. Who's got the answer for 18?
18. 32x to a minus 12.
Why?
That's what you told us not to factor.
I mean, you could if you wanted to, but you didn't have to.
Factor out it.
Yeah, the instructions don't really specify whether to simplify or not. So. Okay. Let's talk about some critical points. Can we what? No. Okay. This whole unit is function. All right. Here we go. What? Nothing. No.
That's so easy.
That's not the homework.
Pretend like that green line is the x-axis. Critical point.
The X and Y. I don't know what you.
What point's critical, Noah?
one on
The one where it makes the line.
Okay, I heard the one on the Y. Which one? You're talking about this one? What's that called? Y-intercept. What else is critical? What's another word for a zero? Give me another word. X-intercept, zero. Solution. Starts with an R. R-O.
What?
Root. There it is. All right. All of those are synonyms. They all mean the x-intercept. What else is critical on this graph?
The curve.
The little humps. There are 3 little humps. Do you agree? Hump 1, hump 2, hump 3. Cortex. It's a cortex. What is this one called? What is this one called? What is this one called? Max. Max, is it relative or is it absolute? Why? No, Mackenzie. It's not absolutely the highest, but it is a high point. So it is a relative maximum.
Look at all the other ones.
That's why it's relative. How about this one? What is this one? A minimum, is it relative or is it absolute?
Relative.
Kenzie, it's not just a guessing game. We have a reason we say the things we say. You are. If you don't know the answer, just be quiet. What? What is he doing? Logan?
Exactly.
Did y'all talk about critical points and okay, all right. So we need to be quiet and we need to so that they can get this because they haven't had it yet. Yeah. What?
Why do we have 2 different things like abbreviated?
Yeah, that's great.
Yeah, like why would we do that? Then I can't tell the difference.
What are you talking about?
Oh,
It's maximum.
The other one's absolute.
The other is absolute. Oh my goodness. Absolute min.
Yeah, that makes sense.
It is absolutely the lowest point on the graph. Okay. While we're here, is this, what type of polynomial is this?
It's a cortex. I just told you.
Quartic. It's a quartic. Let me test you a little bit further. We'll keep.
Wait, what is the fourth?
Yeah, no. I'm just, you will have to, we will get to the point where it'll be there, but I'm just reviewing you now. Okay.
Why not?
Is the leading coefficient, think before you answer this, do not just answer it alone. Is the leading coefficient of this quartic positive or negative?
Positive.
How do you know?
Because
Because both ends go up. Right. Good job.
what if one goes up and one goes down?
It's based on the degree of the polynomial. So you start out with quadratic, which looks like this, right? And then you go to a cubic, which could look like this, or maybe it looks like that. And every time you add a hump, it adds a degree. So this is 2, this is 3. Then you go to quartic, which could look like this, or it could look like this. And it's just the names. And then the next one is quintic. And then we don't give them names past that. All right.
Can you be quiet?
How? I want to make sure I cover everything instead of assuming that you know. So stay with me. And we'll eventually get to the pre-calculus stuff. What?
Why is there 5 pages?
I told y'all to be working on it. How do you find the y-intercept algebraically? Okay, of anything. Y-intercept. Any equation that I give you, you can find the y-intercept of. That's slope. What is true at every single y-intercept? What does every y-intercept have in common? It crosses the y. X is 0. On the right track though, right? Okay, so every y-intercept has an x-coordinate of 0. Does that make sense? Why? If you go anywhere on this axis, right, this might be 0, 5. If I come down here, this might be 0, -1. But no matter where I go on that axis, x is going to be 0 because I don't go left or right any, right? So if algebraically I want to find a y-intercept, then I can just plug in 0 for every x and solve it for y. Okay? Everybody okay? Then flip that thought process. How do I find an x-intercept, also known as a solution, or what's another word?
0.
A 0 or a root. How might I find that algebraically? Make y equal 0. That is why whenever I have a quadratic equation, I set it equal to 0 and solve it, because that gives me my x-intercept or my solution or my root or my 0. Yes? Good.
I used to hate
I used to hate it, but I can.
All right. I'm going to add a little bit of new terminology here with our analysis. And I'm going to use an exaggerated cubic here to make my point. All right. Now, we've talked about relative versus absolute extrema, which are what are extrema? Maxes and mins. Does it make sense why I would call them extreme points? They're extreme. They're the furthest. They're highs and lows, so we call them extrema, right? So we've talked about our extrema. What types of maxes and mins can you have? Relative and absolute. Everybody's okay, yes? All right. Huh? Yes. Are both types of extrema. Yeah. And all of these are critical points. Now, I feel like I got to this in one semester's Algebra 2, but not the other, and I can't remember. Increasing and decreasing intervals. I may have gotten to it in both. Increasing and decreasing intervals. Now, here's the thing. As we describe, this is where things start to get a little bit confusing. As we describe things happening on the graph, we always use x to describe them. In other words, if we're saying where things happen over what interval, we always use x to describe it. If we're talking about a function value, In other words, what's the minimum value? What's the maximum value? We use y for that. But if we're talking about where something happens, we use x to describe it. So for increasing and decreasing intervals, I want to know where that's happening, not what the value is, but where it's happening. I'm going to always use x to describe these. Okay? Now, let me just say this. Increasing intervals mean, and remember, I have to read this graph like I read a book, left to right, okay? As I look left to right, I want to know if my graph is going up or it's going down. That's going to tell me. Going up is going to tell me that I'm increasing, and going down is obviously going to be decreasing, right? This one does do both. So what I have to do is I have to describe, I have to tell where are the places where it's going up as I move left to right, and where are the places that I'm going down moving left to right. So before I do that, can you see where it changes, where it would change direction? Where does that happen? Maxes and mins, right? So these intervals change at maximums and minimums. They could be absolute or relative, it doesn't matter, but every max or min, that's the definition. We call them sometimes turning points, okay? They turn or change direction. So here I've got 1, 2 change of directions here. And I'm going to give some arbitrary values to this. Let's call this 3, 5. I'll call this one 7, 11. Just say, for instance. I don't even know what's coming on. Go sit down.
Don't bite her hand.
Looking at this graph, as I start as far left as I can get, just like I read a book, as I start right here and I move to the left, am I increasing or decreasing? I don't blame you, Miguel. Logan, get your crap together. Logan, I'm fixing to send you out in the hallway. Stop. Okay. Then I turn it to 0.35, and I stop decreasing, and now I'm doing what? Increasing. Here, I stop, and then I start decreasing again. Okay? Understand, if there is no max or min, I don't change my direction. Or if I never change direction, for example, sometimes you have a cubic that just looks like this. I never change direction. I never stopped decreasing and started increasing, or vice versa. No, just right now. All right, get your one.
Oh, okay.
No, it's peanut butter jelly.
Roll one.
Some days I give y'all so much, another day.
Oh, that joke was right. Give me another one.
All right.
Right, it's good. It's not happy. Not throwing them.
Lovely. Go sit down. All right.
Can I sit back here? What if I don't bring my stuff? What if I do bring my stuff?
All right. No. Heather would not be nearly as entertained by the answer. Teresa would. Okay. Look at this one. Look. I want you to look at the little pink graph at the bottom. Notice how it's still a cubic, but there are no maxes and mins. And I know there's no maxes and mins because as I move left to right, I never stop decreasing. I might slow down decreasing. It can stretch out and do that. It might slow down on the rate, and then that gets us into calculus, excuse me, but it never stops going down. It's always going down. So it has no extrema there like that. All right, back up to the example that we're doing. I told you we need to describe the increasing and decreasing intervals. So I need to know, where is it increasing, where is it decreasing? So we'll start with increasing. Remember, I'm using X to describe, and I'm using interval notation just like domain. So on what interval, Davis, is my function increasing? Describe it using interval notation. Using interval notation, describe it. This wasn't yesterday, Logan. You had your hand up. What? 3? And then 7. That's correct. We always do the intervals because technically at the point 3, it's neither increasing or decreasing because it's turning. So we don't include it on the.
But it does touch it.
It does.
So it's a bracket.
It's a, he's right. Okay. How about the decreasing intervals? Negative infinity until 3. And then I need a little u. That's exactly right. 7 to infinity. When you had finished naming your increasing and decreasing intervals, you should have named every part that's in the domain there. Is everybody okay? Increasing, decreasing. Now, no, because I got to name you. No. What if it doesn't increase or decrease? We call it constant. We just say it's constant. Okay. That only, well, you'll have some piecewise. We're going to hit piecewise pretty hard. It's constant.
I remember.
All right, new stuff, constant. New stuff, here we go. Same. He wants his mama to raise paper for him, and he's about to die for her to take him back and tell him she's read it. And because he's got to turn it in for English. All right. We also talk about what we call concavity. Concavity. Okay? Concavity. Have y'all heard of concave up, concave down?
Oh, yeah.
You have? Heard about concavity? Okay. Concave up, if it would, I think about it like if it would hold water. Like hold water. Like it looks like a bowl. Right. My hand is concave up. If it wouldn't, it's concave down.
Do it concave down.
Woo!
Oh,
Doesn't hold water. So, all right. Looking at this graph. How about, what do you see? Is this graph concave up, concave down, or both? Both. What does it do first? This is concave up. Noah. How about this piece?
Concave down.
Now here's the other new part. Where does it change? When does it stop being concave up and start being concave down? On the increase, but it's still increasing, right? So about halfway it stops, and it's kind of hard to see, right? But it does. It stops being concave up. This point is very important. The point where it changes concavity is what we call a point. Does anybody know?
Concavity.
Nope.
Concave.
Thought you knew all this, Logan.
Start with. Don't write it.
I.
I. 1 to 10.
What I?
Start doing it. Yeah. Turn.
Inference.
Inflection.
Yeah. Point of inflection. We do these a lot in calculus. We talk a lot about points of inflection, but point of inflection is simply just where concavity changes. Huh? No. Let me ask you this. Now I'm going to test you. I'm going to make you think a minute. Shh. Can you change directions without changing concavity?
No. Yes, I can.
Wait,
Listen. Can you change direction without changing concavity?
No, you can't. You can't. No, because the only one that would change direction would have a contact.
No, you change. But it's just like this. Because
Not if you go
A straight
flat.
line doesn't change direction.
Because that's not a
A V.
you can still turn as long as you don't go up or down.
It would have.
Okay, we're talking about okay.
No, you
Yeah.
can't.
Yeah.
CBS.
No,
A
you
V
can't.
would be it. I'm right, you're wrong.
That would have a concavity.
Look.
It would hold water.
Just argue with it.
Does that change direction?
Yes.
Does it change concavity?
Yes. Yes, it does.
So I'm right.
So you're right.
Literally has one, Miss McGee. It literally has one.
It has one what?
A concave up.
Right, but does it have a point of inflection?
Where does it change direction?
Where does it change direction?
At the bottom.
At the bottom. At the what?
Vertex.
Give me another name. Absolute minimum or minimum, any minimum or maximum is where I change direction. Right? Okay. Can you change concavity without changing direction?
Oh.
You didn't say a function.
Take out your calculator and graph y equals x to the third.
That's this thing. That's this thing. No, quadratic is only. That's a quadratic. That's a quadratic.
My direction.
Here we go.
X to the third. All right, look. Look at x to the third when you graph it.
Don't look my direction.
Oh,
Oh, it did it.
Miguel, be nice.
Stop.
I'm gonna stop.
Stop. You know that's your key name for it, baby. He keeps feeding into it. I can't.
He's gonna be so bored.
Yeah, I did.
All right. Does it change direction?
Alright, what do I grab?
All right, listen, I am almost done. Y'all stay with me, Logan. I need you to stop. Okay, hit the button that says trace. Hit the button that says trace. And start going. Start going and watch your Y's. My Y is always getting bigger. It never stops getting bigger. It might stop getting bigger at such a fast rate, but it's still left to right, always left to right. It's always getting bigger. So it never changes direction. But if you look at it, wouldn't you say it changes concavity? This is concave down. It's always increasing. It never starts
That one's
decreasing.
changing concavity?
Yes.
How? That makes no sense. How is that one not changing without one?
Concave up and concave down.
Wait, technically, doesn't the parabola always?
All right. Guys, I am struggling today and I need to get through this, okay? Let's get serious. All right, lots of questions about this. What?
Doesn't the parabola always move like in one direction?
No.
Oh, yes, it does.
In the X fact, well, that's how you read it. You don't have any choice but to read it like that. You read left to right. But X tells you where, Y tells you the value. Yeah. That don't change what?
How, that don't hold water. How is that
It
changing?
doesn't hold water.
It's, well, that's a,
It's sideways with it.
all right, what? If you start at the left and you keep like Okay, let's get my spider back over. So I'm over here now, and I keep hitting to the right because that's how I read a graph, is from left to right. Yeah. And as you go right, those y values always go up. They never start, even whenever I get right there in the middle, closer to 0, it still always goes up. It might just go up by a teeny tiny little bit as I go, but it's always still going up. So it never turns. I don't have a maximum or minimum on this, but I do change concavity. Yeah.
Oh. That's like so cool.
POI.